Hello everyone, I trust you are all as well as can be. Welcome to Frontline Systems webinar on simulation and risk analysis using the power of Analytic Solver plus RASON. My name is Dr. Sima Maliki and I would like to thank you for joining us in this virtual gathering to briefly talk about and share some of the possibilities that Frontline Systems software offers to build and run your simulation models and deploy and manage your models as cloud services. This presentation usually takes about 45 to 60 minutes. You are welcome to email your questions to consulting@solver.com. Again, the email is consulting@solver.com. Today, we will focus on Monte Carlo Simulation using Analytic Solver, our authoring tool, working either in Excel desktop or Excel for the web. You just need one license. We will also talk about RASON, Frontline Systems Cloud Platform. First, we will build and test a simulation model together for a software development problem in a startup company. This is usually the first step, developing and testing an analytic model in Excel. But if you want to gain the real business value, you need to get the results of a model into the hands of people who need to use those results and doing so in an ongoing basis. This could be people in operations, sales, manufacturing, customer service, in a form that they can easily ensure it is up to date, rerun the model simulation, either view the results or plug them into another software application or process. We call this model deployment, and today we will talk about RASON. Again, this is our cloud platform for model deployment. I show you how only with a few clicks we can deploy our simulation model to the Azure cloud to run it as a cloud service using Analytic Solver plus RASON. We will talk a little about how to make your model results available to other people using Teams, Cloud, Power BI, Tableau, and we will create our own web application. And this is one way of making results conveniently available to other people. As time allows, I'm planning to show you an example of fitting a distribution based on historical data and explore the options to share the distribution with RASON. Two key components to our product line are Analytic Solver and RASON. RASON is our decision management platform, almost always used from the web as a cloud-hosted or Azure-hosted system that offers a REST API. What is pictured here on the right side is RASON.com. I'm going to change my pen color to red. So this is RASON.com, which is a front-end portal to the REST API that allows you to do a lot of things, including building and solving not only simple models, simple optimization and simulation models, but multi-stage flows that in those flows, data and model results can flow from one stage to another. Analytic Solver can be used as our authoring tool to create and test models by itself, and we are familiar with that, and today we're going to practice that together for those of you who are new to our products. But if you want to share your model results with others, you can achieve this by use of a cloud service. So the good news is that you can deploy your analytic models to the cloud, to RASON server entirely within Excel, and even check runs of your models and manage the models without leaving Excel. And we will talk more about this today. So let's get started. I'm going to open my first Excel workbook. This is the most recent version of Analytic Solver that was released on July 30th. Let's walk through the tabs. On the top left, let me highlight that. Okay, I have the Model tab. Displaying on Model tab displays or hides the task pane. On the Model dropdown, You have access to multi-dimensional modeling that is now available in Analytic Solver Cloud, that it was always available in Analytic Solver Desktop. This tool is very helpful when you are building larger models where there are multiple products, projects, multiple time periods, multiple sources and destinations. And dimensional modeling can help you turn a very complex, hard to maintain spreadsheet problem into a simple, well-structured, easily maintained and expandable model. And it works great with pivot tables. Next is the simulation model group. Let's spend some time here because this is everything you need to build your Monte Carlo simulation model. First is distribution. So let's click on distribution. Here you can access a range of predefined probability distributions. You can select an appropriate probability distribution and its parameters to model the uncertainty of each input variables for your simulation model. But if you're not sure what distribution to use, you can use Distribution Wizard. If you have historical data, this is pretty straightforward. So it's asking you, do you have historical data? And if you say yes, you have to input the data, okay? And then it will help you narrow down your choices, what to do with your historical data. But if you don't have historical data, you can click on next, and then it gives you some ideas where you can find some information and research. And then let's click on next. And here, first step is to determine whether to use a discrete or continuous form for your uncertain variable. So if you have a small number of possible values for your uncertain variable, for example, your underlying physical process involves discrete countable entities, such as number of customers arriving at a service window, then you can use discrete distributions. Prices, volumes, interest rates, exchange rates, weights, distances, you will likely use a continuous distribution. And sometimes you can use a continuous distribution to approximate a discrete distribution. So let's click on continuous, and then if you click on next, it asks you about the bounds. This is another characteristic of your distribution. So what kind of values it can generate, whether they are bounded or unbounded. So if they're unbounded, sample values may cluster around the distribution's mean, but sometimes you have extreme negative or positive values, for example, normal, logistic. Some distributions are partially bounded, and so for example, exponential and other distributions. So you can decide and continue from this point, okay? You will see also that you have access to MATLAB family of distributions. So if you go back to distributions button, under custom distributions, you can see we also offer MATLAB family of distributions, and they can closely approximate virtually any classical continuous distribution, and often they can better fit user data than any classical distribution, okay? And Analytic Solver includes a powerful facility to automatically fit user data to a full range of possible bounded and unbounded and multi-term MATLAB distributions, and we're going to practice that together, okay? So let's get going from here. I'm going to close that. Then you have correlations. So you can induce correlations among your uncertain variable, and then use results button to evaluate the output of your interest in your model. For example, you can compute the statistics. We have measures of central tendency, psi mean, do it. Then we also have measures of variation, variance, standard deviation, and much more. You can calculate risk measures, okay? Mean absolute value deviation, for example. So it calculates absolute value deviations from the mean and more. Okay, you have much more than that. You can see that. Okay. You can use range values to get a grasp of your range of outcomes For example, you can look at quantile measures such as percentile and value at risk. So you have percentile. Usually quantile measures allow you to answer questions such as how much money might we lose with 5 and 10% probability, or what is the probability that we will make at least 100,000? And these questions based on your simulation model, okay? So you have percentile that provides percentiles from 1% to 99%. You also have size target, which returns the proportion of values less than or equal to a target value, okay? Then you also have Six Sigma values, different Six Sigma measures. Next group is the optimization group. This is everything you need to set up your optimization model. There are decision variables. Analytic Solver empower you for deterministic and stochastic optimization problems. So you're fully equipped to use Analytic Solver for modeling and solving deterministic and stochastic optimization problems. You have normal decisions, recourse, normal constraints, chance constraints, different type of variables from semi-continuous to integer and binary and more. Objective, you can have a minimization of a normal objective, expected or chance objective, and similarly for max. Analytic Solver supports DMN business rules and decision tables, decision trees, you can see decision tables, and box function, and views DMN standard. Next, you have parameters tab. Here you can define parameterized simulations and parameterized optimization. Then you have solve action you can use to run simulation and access interactive simulation mode. And next is deploy model. So let's click on deploy model icon. Here, a simulation model can be deployed to Teams, Cloud, Power BI, Tableau, your own application on the web, and make results conveniently available to other people. The purpose of deploy model is to enable your model to be used wherever, whenever it is needed, on the factory floor, on a salesperson laptop, or a smartphone in a call center custom application, okay? With this deploy model option, you can turn an Excel model into a cloud service in seconds without any need for programming, okay? And we will come back and explore these options. Then you have Tools tab. First is Fit. And we'll come back and use example. I will show you an example of fitting an analytical distribution to historical data. Get data allows you to bring data into Excel and a statistically representative sample of data. You have different options for simulation, including how many trials per simulation you want to use, how many simulations to run, what is your sampling method and random number generation method, and much more, okay? And remember, we also feature HDR, random number generation methods. And we will talk more about that later. Let's click on Help. Here you can access user guides, example models for optimization and simulation and stochastic optimization. You can access education and training. To access Solver Academy, there are courses for simulation, Monte Carlo Simulation, advanced courses, and stochastic optimization. And optimization and data mining, of course. Let's quickly look at task pane on the right side. First is model tab. Okay, here you can see the model elements. For a simulation model, you have uncertain variables, uncertain functions, and sometimes statistic functions. Next is platform tab with some options for simulation modeling. Here also you can change trial per simulation and number of simulations to run and much more. You have engine tab mainly for solving when it comes to optimization models, but you also have access to risk solver engine. And here also you can change some of the simulation option from that I showed you. The options kind of overlap. There are multiple places to change these options. What sampling method you want to use or what random number generation method you want to use. Or if you want to set a seed for a random seed for your simulation. Then there's output section that gives you a report of what has happened. Workflow is a topic of data mining that we'll discuss in the data mining webinar. And then you have the tools tab that allows you to cycle through individual Monte Carlo simulations and trials when you have multiple simulations, or you just want to explore different trials. So default value is 1000, so you can change each you can cycle to individual trials and decide what trial you want to display. You can just display the normal sample in your base case, or you can just go from one trial to another and the workbook gets updated. Okay, now we are ready to practice and build our first simulation model. We have a startup company that has a great idea for a revolutionary new computer game. They want to create a simulation model that helps them estimate both the time and cost associated with this new product. And you can see that development stages is broken down into different stages: market analysis, design, implementation. We also have some source of potential delay. And for each development stage, based on their research, they have estimated the number of weeks required to complete each stage using a most likely, best case, and worst case scenarios. And values are recorded here. Accomplishment can be delayed to potential delays, for example, equipment failure, legal problems, or employee turnover. And therefore, you can see these risk factors, and you can see delay in number of weeks presented in these columns. Delay is costly, and you can see that weekly associated cost is presented for development stages and similarly for potential delays. And there's a probability of each of the potential delay or risk factor happening that's presented in column G from 26 to 32. Now, we are going to use Monte Carlo simulation to estimate the total cost and required time to create the new product. Usually, you can start with having an ordinary what-if spreadsheet model. The next step would be to identify your uncertain inputs and specify probability distributions for them using Analytic Solver. And for this example, I will show you can use triangular distributions to model the estimated completion time in weeks for each stage. So to do that, select an empty cell and then let's click on Distributions button. Under common distributions, you can see that we have triangular distribution. Just click on that and it will open your uncertain variable dialog for you. So this is called again an uncertain variable dialog. You have the PDF tab, CDF displaying a chart of cumulative form of distribution function. You have the reverse CDF. On the right hand side, you have parameters. Okay, there's a drop down menu. First one is parameters. You have access to analytic moments, percentiles, chart type, access options, and much more. You can also add a marker. Let's go back to parameters. I'm going to move it here so you can kind of follow me through. So we have to adjust the parameters now. And we're going to point to our most likely best case and worst case values. And you can drag and drop the formula. So first is mean. Here under default values, you can see that we have 0, 1, 3. So if I change the mean to our best case 8, it would be greater and likely and max on the default values. So the chart would disappear. So let's go mean, best case, D15, most likely 12, C15, and max is worst case E15. I click OK. So now we have adjusted the parameters. You can verify that we have done everything correctly, 8, 16, and 12, right? Now you can click on Save. And now we have a triangular distribution to model the estimated completion time for market analysis in number of weeks. Let's repeat that for bad design. Everything else I've completed for development stages, and then I have only one for potential delay for bad design. So similarly, select an empty cell. You can also type in our functions work greatly with formula, insert function of Excel, and then click on distributions, go to common, triangular, And then let's adjust the parameters quickly. This time I'm going to start from max and go toward the min. Max is worst case, E26, most likely is 8 in C26, and min is best case in D26. Now let's model the occurrence of each potential delay. You can use a Bernoulli distribution. So select this empty cell, go to distributions. Bernoulli distribution is a discrete distribution. So click on discrete group of distributions. First one is Bernoulli. It takes value of 1 with success probability and value of 0 with failure probability. Now we have one parameter to adjust. This is the probability. So let's move this chart here. And I have to point to the probability of event, which is 20% in cell G26. And as soon as I click OK, you will see the chart gets updated. We get 1, 20%, and 0, 80%. Now click on Save, and we have the Bernoulli distribution to model the event occurrence of bad design, the risk of bad design. So I multiplied everything and calculated total cost for development stage. Similarly, we calculate total cost for potential delay and also add up everything for additional week required. So we have two functions of interest, one in cell I35 and one in K35. Cells I35 and K35 contain the uncertain functions which model the project's total number of weeks to completion and the estimated total cost. So we need to select outputs to record over the simulation trial. We need to let Analytic Solver know. There are two ways to do this. One is that the simplest way is to select a cell, for example, K35, and then go to Results, Outputs in Cell, the first option. And it designates the currently selected cell as an uncertain function and record over everything for us, okay? You could also calculate a summary statistic. For example, you can calculate the average number of weeks to completion. And for that purpose, Analytic Solver record over all the trials to calculate the average for you. So let me show you how you can actually calculate some of the results. So select your function of interest. So we have total number of weeks to completion in cell I35. Now go to results, statistic. Let's calculate the mean and then place it in an empty cell. So this is for us the mean, the average time. Okay, this cell. By doing this, we are ready to execute simulation for a number of trials and analyze the output. So let's go ahead and click on Simulate, Run Once. We just ran 1,000 Monte Carlo trial, where on each trial we have a different randomly sampled value for delay for each stage and event. Then we calculated total cost and total time. So this is K35, this is I35. So this is a frequency chart that shows the distribution of all possible outcome for our total time. Let me show you. You can look at the statistics on the right side and the drop down. So this is a drop down menu. You can see that the total time can be anywhere from a maximum of 99 weeks to a minimum of 46 weeks with an average of 72 weeks. Going to walk you through different tabs that are available here. So we have the frequency chart, we have the cumulative frequency, reverse. You have the sensitivity tab that displays a tornado chart showing you which input has the most influence on this statistic function. Okay, here total time in the project, and H26 has the most influence all the way to the F19 that has the least influence. And then you have individual scatter plots. Okay. When you run your simulation, you might see more charts. The reason I'm getting only the frequency chart for I35 and K35 is that in the drop-down, you can choose, you can go from statistic to percentile, Six Sigma, chart type, and then is chart option, and chart option you can choose to display this chart after each simulation, and this option would only allow this chart to be displayed. So any chart you select, they will be displayed and other charts will be eliminated. The drop down, you also have access to axis option. You can change the labels and then you can add markers and much more. Now, next one is K35. This is the frequency chart that's showing the distribution of all possible outcomes for our total cost. Okay, and this happens, what can happen, this shows us what can happen with these specific assumptions. Okay, let's close this. So this was our first simulation model. We built a model, we run the results, we looked at the outcome, and now we are ready to learn how we can go beyond just model development, how we can share the results and move along into deployment. So we want to be able to promote our model, to be able to run it on a cloud service and make it available to other people, because from a cloud service, other application can easily access the model and run the model. If the model is capable of running on a cloud service, here we're just able to run the model on Excel using Analytic Solver for Excel, right? Let's click on deploy model. If you aren't sure where to start or what you need, you can always use Deployment Wizard. This is the step-by-step help showing you what you can accomplish. So let's click on Deployment Wizard. Let me show you. So gives you some information of what is possible, and then you can choose, hey, what do you want to do? And then you can say, I want to run my model on a desktop or server PC as part of a custom Windows application. Click on next, and then you can continue with reading all the information that you need and then try it, okay? So let's go back to deploy model and I will try to show you some examples. Let's start with cloud service. First one is Excel. We are going to post the Excel workbook itself to the RASON server and run it on the server as Excel workbook. So let's do that. Select Excel model. Here you need to give a name to the model. Your workbook can reside on OneDrive. Okay, so I can just accept the default name and click on save. So this way, a copy of the workbook will be saved on our RASON account, RASON server, cloud server, and by clicking on save, a copy of model will be saved to the Azure cloud. So let's click on save. Our Excel workbook during this time is being saved on RASON server. Immediately you see that rason.com opens and displays the model within a few seconds, as you can see, without translating the model into RASON language. So this is the model, just like an Excel workbook, as you can see. So with this action, our Excel model itself is posted to RASON server. And we are seeing a copy of it on rason.com. This is rason.com editor page or web IDE. Let's see what we have here. We are looking at RASON through a front-end portal, rason.com. So in the background, there is a REST API service that can be used by any application. RASON.com itself is an application that is connected to the backend server, okay? This is called the RASON editor, okay? So this is where the model is. Let me walk you to the different section. On the left-hand side, these are all the models I have under my account. And here in the output, you can see how the communication with the server is happening. To get a copy of our model here, we had to pass a get https rason.net and then the name of the model. And on the right-hand side, this is specific properties for each model that's open. Now, on the top, we have some execution option, so we can solve this model on RASON 7 and get the results, okay? So let's click on post. This is a simulation model. We can click on simulate. It will solve the model, first loads it. So we're working with the server in the background, right? So we get a copy of results here after it is completed. These are all the trial values for I-35 and K-35 and percentile values and everything that we requested, okay? And down here, you can see that how this communication, how the call to RASON REST API is happening to get the status and to get the results. This is called JSON syntax, okay? The results can be available in OData format also. To do that, let's go back to model, go to post, solve. It will run the model, parse, diagnose, solve. And now these are results available in OData format. This is I-35, average number of weeks to complete the project, 72 weeks, different trials, everything in OData. And in the right-hand side, you have the option in this corner. Let me highlight that. You can switch between OData and JSON results. If you go to RASON.com, you can see that RASON stands for RESTful Analytic Solver Object Notation, a modeling language in JSON syntax, and a REST API. And then you can go back to editor page. Okay. Now let's go back to Excel and try one more way. So let's click on deploy model. This is our model. Again, cloud service. We are going to deploy deploy further using cloud service and RASON modeling. This time we're going to, okay, let's go back to Excel. Click on deploy model cloud service. This time we are going to translate the Excel model to RASON modeling language, to JSON syntax. Everything will be done automatically for you. So let's click on that, give model a name, click on save. Immediately again, the browser would open and displays the model in JSON language in RASON.com. So it takes a few seconds. Here is the model. This is the automatic translation of our Excel model into RASON modeling language. And our software automatically translated the Excel models, formulas, data into equivalent expressions in RASON modeling language, okay? And then you have the option, again, to go ahead and solve this. Get the results back from the server. Again, results are available in OData and also in JSON. Okay, I have a summary slide I want to show you. Let's skip the setting of simulation model step. So here's this slide. So what we have done is, so far we built the optimization model in Excel. Okay, so I built a model. Then we clicked on create app, created cloud service, and we promoted our Excel model so we can run it on RASON server. And we posted to RASON server as a cloud service in two formats. For a simulation model, we could post the Excel workbook itself, or we could translate everything to RASON modeling language in JSON syntax. And they're promoted, they're sitting on RASON server, and we saw how with the front end portal, RASON.com, we could communicate. We saw a copy of model here, and we were able to communicate with RASON server, solve the simulation model, and then get the results. And results were available in two ways, JSON or OData. Let's go back to Excel now. Click on deploy model, and let me show you the manage model. This option that you have. So manage model allows you to see all your models and various version of your model on RASON.com. Everything will be displayed here. So all the models you have on your RASON server account will be displayed here. You can open a model, check on versions, and actually check runs and delete the model. So everything is possible from Excel, okay? You can work on your models, post them to the server, and then manage them from Excel. Analytic Solver includes the ability to bypass months of development work by creating a web application for you in few seconds that can solve the simulation model and much more optimization models, stochastic optimization, and decision tables in Excel, okay? So I'm going to show you how you can create a web application. Sorry, let's go back to Analytics. Let's go back to Analytic Solver Deploy Model, and let's go to Quick Test, and you can click on Web Page. And immediately Analytic Solver translates the Excel into RASON. A browser opens, displays the newly created web application, and creates a web page for us with some textbooks and buttons. This template is shipped with our product, so you can actually use it and change it. Here is the RASON translation of the model, all of data embedded in JavaScript code on this page. This is the working version of model that can run on the web. So if you click on solve or quick solve, automatically the model is submitted to RASON server and the simulation is started with RASON REST API endpoint post. So let's click on solve and you can see I'm posting to RASON server and it's going to solve the model and yet get the status update. When it is completed, the results will be displayed here. So you can see first was incomplete, then a status is completed, and here are the results. All the solutions that we saw in Excel, now you can see them in this web application. Just within a few seconds, right, we created a web application. You can always right click, view source. You can see that we have HTML for edit fields and buttons, and then we are using JavaScript to pass the model, get the results, and communicate with RASON server. And then we show you how you can connect with different endpoints with solve, delete the model, get a status, and much more. So everything you need to start your web or mobile application. Similarly, this option is available from rason.com page. On the top, you can see that there is a create app option. Exactly similar, you can connect to create an application. You can use this to connect to Power BI and Tableau. Now we can look at the issue of distribution fitting. I promised that I will show you one example. So let's go back to Excel. I'm going to close all these tabs. Let's click on Help, Example Models, and let's click on Monte Carlo Simulation Examples. Let's scroll down and let's open College Fund Example. So I want to show you how you can choose a distribution based on your historical data. This example is available. I'm not going through the details, so the focus is just on distribution fitting. So, but in a summary, this is a college fund growth projection, and we are simulating for a number of 20 years the return on S&P 500. So this is a portfolio return using a MATLAB distribution, and the MATLAB distribution has been fitted to historical annual returns on a standard index in this example. But I want to show you how you can do that, okay? So imagine you have this historical data and you want to see how you can fit a classical distribution or a MATLAB distribution to your historical data. So let's select the historical data. Okay, and then click on Analytic Solver. And then let's choose Fit, Tools, Fit. You can appreciate that you have classical and MATLAB distribution for distribution type. Let's leave it to both. So we can see both of them. Here you can choose your sample data and decide whether it is continuous or discrete. With the data is annual rates of return, so we can keep continuous selected. Next is distribution options. You can run sample independence test. So when fitting a sample, when fitting a distribution to a sample of data, it is important that trial values are not in any way correlated with each other. So if you want to run an independent test, you can leave this box checked, okay? And Psi interpreter will run an independence test and will report an error if the trial values are found to be dependent, okay? And then for continuous data, you can, for continuous distribution and data, you can choose goodness of fit test. I'm just going to leave the default setting. And if you have discrete, it would be different. And then you have MATLAB options. You can leave the max term 16. and then you can leave bounds, and then for lower and upper, the lower bound must be a value lower than any data points, and upper bound must be a value greater than any data point. So let's enter negative 50% for lower and 0.60% for upper, and click on fit. Let's erase all the drawings. So Analytic Solver computes and displays a ranked list of candidate fitted distributions, as you can see here. Initially, the distribution with the best fit statistic is shown in the chart that overlays the sample data, and you can see that this is the MATLAB distribution with 14 terms. Down here, you can change number of bin size or size of it with moving it to the right or left for this histogram. Inside dialog, there is a list of choices for distributions that can fit this historical data in the order of decreasing goodness of fit based on the test you choose, okay? And you have the option to compare multiple distributions, so you can compare MATLAB with, if you scroll down, maybe we have a normal distribution somewhere. There it is, you can compare it with a normal, or just go ahead and just choose the MATLAB distribution. So you could compare different choices, and then on the top, you have the different tabs to get additional perspective on this, which distribution best fits your data. So here you have the probability chart. This graph is used to determine how well a specific distribution fits the observed data. And the chart will be approximately linear if the specified distribution is the correct choice. You also have quantile chart. And if the two distributions being compared are good fit, the plot will lie approximately on the x equals y line, this line. You also have the cumulative distribution function difference chart that quantifies the difference between the empirical distribution function and the cumulative distribution function of this distribution. You also have the MATLAB panel that you can see all feasible MATLAB density functions. Let's click on fit. Okay. Once you're happy with the result, you can click on save and choose a cell to have the distribution. I placed it in cell J2 and click on save. Okay, so we have the J2, which is a MATLAB distribution with all the parameters. Now you have some more options. You can actually deploy and share this fitted distribution. Let's click on deploy model. Let me show you how you can share this MATLAB distribution. So MATLAB distribution actually have a specific property. Let me talk more about that. So remember we have, let me go back to options. Remember the HDR, random number generation method. So you can do something very special with MATLAB distribution. MATLAB with HDR, random number generation method, has the property to allow you to essentially randomly access any number in the random number stream without having to compute all the numbers to that point in the stream. So if you want any trial, you can obtain that value directly. So you can save this distribution and share it, which I will show you in a second, in a form that anyone in your organization that reuses the distribution, they will get not only the general behavior, they will get exactly the same behavior down to individual Monte Carlo trial. And you can see that this is, you can appreciate this is very valuable if you want to compare things apple to apple and you want to share this distribution, and then it always reflects the same outcome that you want all the way to individual Monte Carlo trials, and it's going to be advantageous. So now let's see how we can share this distribution. There are two ways to do this. One is just to save it on a local machine. So let's go to deploy model, quick test, and you can click on deploy model, quick test, probability, choose what we have in J2, add it to selected distribution, and click on save. And we can give it a name. Let's call it 222 and click on save. And now I saved in my webinar folder 222. It's a JSON file, the MATLAB distribution with all the fitted parameters that you can share. If your data are confidential, now you can just share the fitted distribution. This is only on local machine, okay? Now you can do much more because we have the power of RASON server. So let's click on deploy model, cloud service, probability model, and we can export the distribution to RASON server under your account. J2, add to selected distribution, and click on save. Within a few seconds, here is a distribution in JSON syntax. Now it is sitting on RASON server and ready to be used in any of your application. Okay. You can also import it back. So imagine you want to import this distribution in this model. So let's go to distributions button on the ribbon. And on the top right corner, you have the option to import model. So let's click on import. And you can choose the probability model. So I have college fund. And you can choose the distribution in J2, and you can enter, for example, in cell G5. Okay, let's enter it in G5, and it will import the MATLAB distribution for us. You can see that we had it on server. Now it is imported in cell G5 and can be used in this model. So imagine you have the historical data, you know it will exactly do the same behavior, and you can share distribution with someone and they can import it and use it in their building with their Monte Carlo simulation model. And this is very advantageous. Okay, this concludes what I want to this concludes what I wanted to share with you today during the time we had. Let's go over a summary of what we just practiced. Excel would make it easier to get started with analytics, and you have Analytic Solver with the full power for creating and testing analytic models. You have Analytic Solver Desktop that works with Excel, and Analytic Solver Cloud that works with Excel for the web and offers all the tool you need from the convenience of your browser. Actually, let me show you quickly. So I'm going to pause this screen for a second, and let's see. And here it is. So I have Excel for the web, and here is Analytic Solver, same ribbon with all the power you can use from the convenience of your browser, okay? We have two key components to our product line with Analytic Solver as authoring tool, and we have RASON server. With the power of these two, you can promote your models to run them on RASON cloud service and make results available to other people. And you can just do this with point and click. And we are offering you a cloud service that can serve the purpose of saving, maintaining, and then running your analytic models in the cloud. And you can have different clients that can talk to this backend server. It can be Excel for the web, Power BI dashboard. You can create data connections and much more. So RASON combines predictive and prescriptive analytics, and it offers more. It enables you to use the results of analytic models to drive your operational decisions and actions. It also does that by supporting rules and decision tables, and also exposing analytic model results as JSON and also OData inputs, which are always generated and they can be consumed by lots of software directly. And our products work greatly with Microsoft Power Apps, Power BI, Microsoft Teams, and much more. You can do much more. You can embed your Excel workbook directly in these multi-stage decision flows, and you can combine SQL, RASON, Excel, and DMN models, passing results from one stage to another. So again, this screenshot shows you a multi-stage decision flow in RASON, and you can use it as a flow. And then this diagram editor can be used as a drag and drop tool to create a multi-stage flow, and you can actually flip back and forth between RASON modeling language view and diagram view. Okay, so there's this option in the corner if you're interested to explore more about this RASON power. If you're interested, you can explore that and switch between RASON modeling language view and diagram view. And you are able to perform automatic scheduling. I really enjoyed presenting this webinar, and I trust it was helpful. Here is our contact information, consulting@solver.com, a phone number to call for tech support. But if you have modeling questions or if you have any questions about this webinar, email me at consulting@solver.com. We appreciate your time and look forward to connecting with you. Have a wonderful rest of the day. Bye for now.